Good morning, everyone. So this video is just to explain Pascal triangle, and if time permits me, I'm going to explain binomial expansion. So how does Pascal triangle works? So the first thing you need to know is binomial expansion. Binomial expansion is just like expanding something. Like what you just want to expand as a new sound. So in our secondary school days, or let me just say our primary school days, we know this x plus y raised to power 1 is the same thing as x plus y. Then x plus y raised to power 2 is what? X squared plus 2xy plus y squared. But once the power of increase, let's just say x plus y raised to power 6, how do we solve it? Though we can still use our junior school knowledge to solve it, but it will take time. That is what will lead us to this topic that we want to discuss, binomial expansion. Like I do say, every topic we treat in math, we are trying to solve a particular problem. So the problem binomial expansion is solving is expanding. One of the problem is solving is expanding numbers when the power is increased. For example, 6. So how do we solve this binomial expansion? Or how do we solve this expansion? There are two ways we solve. One is the what? Pascal triangle. One is Pascal. Let me just put method of solving binomial. One is Pascal. The second one is what? Binomial expansion. So I'll use this video. This particular video will be used to explain Pascal. So for Pascal, how does Pascal work? This is how it works. So it is called Pascal triangle. This is how it works. So it is used for what? X plus y all raised to power n, where n ranges from what? When n is greater than or equals to 0. Don't worry about it. We'll look at it very soon. You see, if I put x plus y all raised to power 0, what will it give me? 1. So I'll come here. I'll put 1. If I put x plus y, take note. Okay, before you take note, if I put x plus y all raised to power 1, what will it give me? X plus y. Take note, what we put here is just the coefficient. If I say x plus y, what is the coefficient? 1. And what is the coefficient of y? 1. You get? So x plus y all square, what will it give me? X squared plus 2xy plus y squared. What is the coefficient? 1. What is the coefficient? 2. What is the coefficient? 1. But if I keep on doing the remaining one, if I keep on doing, if I, like now, this was x plus y square now. If I keep on expanding it, it's as if Pascal triangle is not doing anything, because I'm trying to expand it. And why we are looking at a particular method is to make things easier for us. So that is what a good friend of mine, Pascal, is solved. You notice that, you see that I started with 1. Nothing plus 1. This is how I did it. Before this one, you see that there is nothing here. Nothing plus 1 will give me 1. 1 plus nothing will give me 1. Then that's how I got this 1 and 1 here. This one here, nothing plus 1 will give me 1. 1 plus 1 will give me 2. 1 plus nothing will give me 1. So let's go to the third one. What will the third one be? Nothing plus 1 will give me 1. 1 plus 2 will give me 3. 2 plus 1 will give me 3. 1 plus nothing will give me what? 1. So this one is for x plus y raised to power 3. Then the next one. Then you now notice that, so you notice that it's starting from 1 and it's ending at 1. So what will you do? He put 1 here and ended it at 1. So he started adding. 1 plus 3 is what? 4. 3 plus 3 is 6. 3 plus 1 is 4. So this one is for what? X plus y raised to power 4. Then like that, 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5, and this one is 1. So you notice that, so that's how you do for, so this one is x plus y raised to power 5, and like that and like that. Do you get? So that is the Pascal triangle. You notice that it is forming a triangle. It is forming a triangle. Have you seen? That's why it's called Pascal triangle. So how do we now solve question on Pascal triangle? There is something you need to notice about expansion. You see, when we did x plus y all square, the power, maybe you should write down the power of the variable before the sign will decrease, while the power of the variable after the sign will increase. Look at the power. It was 2, so it will decrease x squared. Then you see this one is x raised to power 1, then the last one is x raised to power 0. You see this y, initially it was y raised to power 0, the next one is y raised to power 1, and the last one is y raised to power 2. So if we get that, let's just solve this. X plus 2y all raised to power 4. Let me just say all raised to power 3, because you and I know that the power of this will be reducing. What is the one before the sign? The one before the sign is x, so you just put x cube. But you notice something, when I did that power stuff, I was not able to get this 2. I was not able to get this 2 here, and I was not able to get the coefficient here. So that is where Pascal triangle comes in. All these values that you are seeing here in the Pascal triangle, they are called a binomial coefficient. Just take note. So let's solve this. This one is x cubed, then plus, you know that initially this is 2y all raised to power 0, because what is after the sign is what? 2y. Then it becomes plus 2y raised to power 1, because I told you that it will be increasing. Then this one will be x what square. The power of what is before the sign will be reducing. Then plus 2y raised to power 2. Then this one is x. Then plus 2y all raised to power 3. So after doing this, you have done that's the general method of expansion. Then you notice that this is raised to power 3. Where is raised to power 3? See it here. What is there? 1 3 3 1. You notice we have not used it, so we will now put it there. You just put 1 3 3 1. So that is that. So this one will just be x cubed, because anything raised to power 0 is 1 times x cubed. Then this one is plus 3 into bracket 2y x square plus 3 into bracket 4y square x plus 8y cube. So this one will now be x cube plus 3 times 2x square y is 6x square y plus 12xy square plus 8y cube. So that is, you see that is correct. The power of x keeps reducing by 1, while the other one, power of, or let me just say power of whatever that is after the sign. Don't let me be using x. That's I say whatever is before, the power of whatever is before the sign will be reducing, while the power of whatever that is after the sign will be increasing. So that is it. So let's just solve something. Let's just do 2x minus 3y raised to power 2. So the first one, using the method, what is before the sign is 2x. So you come here, you put 2x, then raised to power 2. Then what is after the sign is minus 3y. You know that what I taught you earlier was x plus y. So yeah, I'll just put plus, you just say 2x plus minus 3y. Let me just show you what I mean. 2x plus minus 3y, then all square. So it will be 2x square. Then what is after this plus sign? Minus 3y. So it will be minus 3y raised to power 0 plus 2x raised to power 1, then minus 3y raised to power 1, then plus 2x raised to power 0, and minus 3y raised to power what? 2. Then you now recall, since it's power 2, what we use? 1 2 1. So you come here, you put 1, then come here, put 2, and come here and put No, sorry, come here, put 1. This one is still 1 because it's still the first one. This one is the one that is having 2. So once you simplify, so 2x all square is what? 4x square. This one will give me 1. Entry raised power 0 is 1. Then 2x times 2 is what? 4x times minus 3y is what? Minus 12xy. See that the power of this one reduces by 1, while the power of y started to increase. This one it was 0, now 1. Then plus, because minus 3y all square. How did I get minus 3y all square? In case you did not see it, this one, you know that it was raised to power 0, this one will be raised to power 1, and this one will be raised to power 2. That is plus 9y square. So that is how simple it is. So you guys should try this. It's for only scholars, but I know you guys are scholars. X minus 3y all cube. So try this. So in the next video, I'm going to explain combination method. So there are 2 methods. Sorry, one is Pascal, the second one is combination or binomial expansion. So we'll look at the combination method in the next class. But let me just tell you why we're studying the combination method now. You see that if you are given raised to power 20 now, or let me just say raised to power 5, and you are told to find, let me just say raised to power 7, and you are told to find the particular term, just let's say the 4th term or the 7th term, will you be doing this table? No. That is when the combination comes in. Imagine doing all this and you are told to find just this term, only this term. It will make sense, to be interesting if the power is still small, but once they give you like 10, it's not advisable to do this. Though if you do this, you get it, but you will waste time. And what I said earlier, that why we are studying all this is to solve a particular problem. So the particular problem that combination method is solving is what I have said, is to find a particular term. So please, if you don't get it, feel free to let me know wherever you are seeing this video. Thank you. Bye for now. I'll send the video on combination method